Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, just know you will be able to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question, and we'll try to get to as many as we can before the end of today's webinar. And also at the end of today's webinar, we will be doing a drawing for two $50 Amazon gift cards. So please stick around. Hopefully you'll be one of our 2 lucky winners. Okay, with that, we will go ahead and kick off today's webinar, which is Effective Cost Management for Azure Databricks. Our speakers today are Jason Beck, who is Senior Director of Product Marketing at Unravel, and he's being joined by Scott Sumner, who is the Director of Solutions Engineering at Unravel. Welcome, gentlemen. Thank you so much for joining us. Before we get things kicked off, Jason, I know we have a quick polling question that I'm going to go ahead and push out to the audience right now. And if the audience can just take a few seconds here and answer the question, which is, what is your biggest challenge in managing the cost of your Azure Databricks environment? You can select from predicting cloud infrastructure capacity as trial and error. I don't have enough granular visibility to cloud spend. Correlating metrics to a single event is a challenge, or none of the above. I'm not concerned with costs. Okay, we'll give you guys a few more seconds to go ahead and make your selection, and then we'll close the poll out and I'll hand things over to Jason. Okay, looks like we are looking forward to this topic today, guys. I think it's going to be really, really interesting. All right, we're going to go ahead and close it out in 3, 2, 1. Okay, so here are the results. It looks like I don't have enough granular visibility to cloud spend. So Jason, I'm sure that has everything to do with your webinar today, your webinar presentation. So I'm just going to put myself on mute. I'll hide these results and let you get right to your presentation.
Awesome. Thank you, Charlene. Good morning, good afternoon, good evening, wherever you happen to be. So I wanted to, first of all, welcome you to our webinar today, Effective Cost Management for Azure Databricks using Unravel Data. So I'm Jason Beck. I'm the Senior Director of Product Marketing here at Unravel. And I'm joined today by Scott Sumner, who is Director of Solutions Engineering at Unravel Data. So we'll cover a couple of topics today in showing some of the techniques around cost management for Azure Databricks that we've seen. And we'll go through those techniques and some of the benefits our customers have received by using Unravel Data for the insights and recommendations that they've been able to receive using our tool. We'll start with that. We'll start with a short overview on the topic of cost management for Azure Databricks, and we'll actually have Scott go through a very thorough and deep dive demo of Unravel for Azure Databricks to show you those techniques in action. And we'll have a chance to interact, and we'll have a chance to answer any questions you may have around this topic. So prior to diving into Azure Databricks, what I wanted to do is just share just a quick overview on why Unravel. So in addition to the monitoring and management of Apache Spark and Azure Databricks, we do support the entirety of the big data ecosystem, including the entire Hadoop ecosystem, open source projects like Kafka, HBase, etc., as well as the hyperscale cloud providers such as Azure, Microsoft Azure, as well as Amazon Web Services. We have strong market validation. We actually have a number of financial services customers across the world and in the United States, as well as healthcare customers and telecommunications customers as well. And we manage about 15,000 nodes across these variety of different industries. And we're backed by an experienced team of big data experts in the industry, with our founders and many of our engineering staff coming from companies like Cloudera and Hortonworks. So in these uncertain times, what we've heard from our customers is that data ops are more critical than they've ever been. And the consequences of missed service level agreements go way beyond cloud cost and storage and compute. And I'll share with you a few anecdotes that our customers have shared with us on the role that data operations is playing in the current world and the current business climate. So we all understand that there's a number of different stimulus packages announcements that are rolling out almost on a weekly basis. And what's happening, unfortunately, is that there are a number of fraudulent claims that are happening with our banking customers. And these fraudulent claims, the quickest way to identify and resolve these fraudulent claims is through artificial intelligence systems backed by big data. So not only are tools like Unravel helping to resolve cost issues and performance issues, but not banking on the tools for productivity and efficiency could lead to millions in theft and fines. So it goes way beyond just infrastructure cost. It can lead to much larger volumes of cost in the financial services and banking sector. And similarly, I think we've all seen the headlines around healthcare. There are capacity issues and resource allocation issues all over the world. And our customers who have used these big data systems to profile patients to accurately describe conditions like meningitis or sepsis are using the same operational systems to identify patient profiling for COVID-19. So you can imagine the inefficiency that may arise in a field job or a field application could be catastrophic in terms of the poor allocation of resources. So just a few examples that our customers are telling us are the consequences of missed service level agreements. So why Unravel for Azure Databricks? So we've been supporting Azure Databricks customers for a little while now. And what we found is that customers are often receiving a kind of sticker shock in between what they expect and what they actually get in their cloud bill. And what we like to do is point out really cost savings either directly or indirectly by helping them manage cost, helping them manage performance, and also helping them manage their migration to the cloud from on-premises intelligently. So what do I mean by that? Well, in terms of what our tool inherently does is that it provides fine-grained visibility into the metrics and the drivers of the telemetry behind your Azure Databricks system. So we're able to, by providing that fine-grained visibility, cut costs between 30 and 50% simply by putting out the right cloud instances that you should be using in your Azure Databricks environment. Right? That's just an example, and Scott will go into more of that in a little bit. We also provide a huge productivity boost in terms of managing your performance. So those same metrics that you're now exposed to in the fine-grained visibility will quickly allow you to diagnose issues and really cut down that mean time to identification and resolution to stabilize your system and get on with your application's tasks. So we're able to free up 50% or more in wasted time and productivity. And our customers find that very valuable in using Unravel for Azure Databricks. And finally, for customers that are looking to save costs and save cloud costs in terms of infrastructure costs in terms of migrating to the cloud. Let's say you have an older legacy Cloudera or Hortonworks system that you want to migrate over to Azure. You're able to confidently do that with intelligence using the data that we're able to collect for your on-premises Cloudera or Hortonworks cluster. So because we have a rich heritage around Hadoop, we're able to automatically inventory your cluster's resources, get into fine-grained analytics, and provide a GPS mapping to the cloud to show you exactly which path you should take to get the most optimal outcome. And that's all backed by an experienced big data team. So let's take a minute and talk about the total cost of ownership of running a big data infrastructure like Azure Databricks. And according to a recent IDC economic benefits report, it shows that 50%, over half of the cost of maintaining the total cost of ownership of big data systems like Databricks is actually in IT staff costs, right? So you would think that most of it is due to infrastructure and software costs like compute, networking, and storage, but it actually goes beyond that. Most of the cost is due to the software cost of troubleshooting and managing capacity. And if we drill into that a little bit, we could see that the top 5 productivity costs, as our customers are telling us, are things like poorly performing or failed jobs, right? So maybe you can identify the failed jobs, but getting to the root cause of failed jobs and getting to optimizing those failed tasks and those failed jobs is really problematic for our customers. Also, that leads to huge misses in service level agreements where customers are just not able to provide the uptime and the reliability that they promised their customers, their end customers, which inevitably leads to a pointing fingers or blame game of the application team saying it's the cluster resources that are improperly configured, or perhaps it's the operations team pointing fingers back to the applications team saying, well, you wrote some bad code that's making this happen. And finally, what would be great is if we had an efficient way to provide some sort of accountability of the cluster resources, but that simply is just not the reality today. And customers are often having to piece together manual reporting from hundreds of lines of logs and disparate tools experiences to drive that accountability. So you could try to address this in a manual fashion, right? So you have many of our customers kind of start down the road of a very arduous trial and error process of properly sizing Azure VMs, or trying to configure Azure storage and networking in a manual fashion. And it simply is a time waster for many of our customers, right? So they use free tools like Spark Web UI. And if you're versed in these tools, if you have expertise around it, it could work, but it still would take you a tremendous amount of time just to correlate that information to the context of a specific job or an application. Right, and so that's really what our tool aims to solve. And Scott will show you many examples that we've come up with of putting these techniques in action. So the Unravel solution. So our aim is to make everyone in your data team an expert in data operations analytics. So we provide a unified view for all of your data pipelines from end to end, providing a single pane of glass for all your data operations needs. So whether you have Hive in your environment, whether you have MapReduce, Spark, of course, we're able to give you insights and recommendations for exactly what's happening in your environment and how to unblock those inefficiencies. We're also able to provide insights and recommendations to actually improve the performance of your big data pipelines. And we do that using your own data's telemetry. We collect a lot of the operational metadata that's naturally occurring in your Spark system or your Hive or your HBase, et cetera. And we're able to provide things like container sizing or different memory allocations to really, with accurate intelligence, give you recommendations on what those settings should be, right? Which will save you tons of time in terms of regained productivity. And once you have a pretty good idea of what those settings should be, we have automatic remediation that allows you to either send an alert or provide that in a report or some other workflow fashion like PagerDuty to allow you to minimize the hands on the keyboard that you actually have to pay attention to. So just showing you a few more screenshots, and Scott will go through this in more detail. But we do have chargeback and showback capability to drive, again, the accountability back to the user or the department or the application that's a huge consumer of the big data resources. We also give you recommendations on the proper allocation of the cluster resources, such as the correct VM type and VM flavor that you should be using for Azure Databricks. And again, we have a very robust alert and auto actions capability that allow you to take immediate automated action for low or high watermark situations like memory usage. So what's making all of this happen is our extensible data operations platform. Right? So we have something called adaptive data collection technology, which is a set of lightweight sensors that will take all of the rich operational metadata and telemetry from all of the platforms that we support. So things like open source projects like HBase and Kafka and Spark, whether they're hosted on premises, right, like Cloudera and Hortonworks, or whether they're hosted in a platform as a service like Amazon EMR or HD Insight from Azure, we're able to monitor and manage all of that and pull all of that data into our Unravel system using this adaptive data collection technology. And the secret sauce here is that we really allow you to correlate that data in the context of a single job or a user or an application so that you don't have to try to do this manually on your own to get the insights and recommendations that we provide automatically. And again, we're able to provide this in the form of a report through auto actions or enable you to access our API so you can use it in subsequent applications as well. Okay, so just to give you a few other points of data to help you evaluate Unravel. In terms of the total cost of ownership, I think the point here that we're trying to make is that the cost of your big data system in Azure Databricks go way beyond just simple infrastructure and software. We do provide that insight and intelligence to allow you to save on the hard infrastructure costs, right? So you see some figures here as an illustration, but really the value that we provide is the productivity and the labor boost that we provide by allowing your application providers or application developers to serve themselves to what's happening in your Azure Databricks environment. And also resolving that mean time to resolution or mean time to resolve your job failures from days to a simple matter of minutes. So that's really the value of Unravel, is that we are not only a infrastructure cost saving tool, but we're also a productivity booster as well. And what Scott's going to do at this point is provide illustrations through a demonstration of our product, Unravel for Azure Databricks, to show you what these techniques look like in action. And we'll answer some questions after that. So Scott, I will hand it over to you. Give me a second just to give you presenter access.
Sounds great. Thanks, Jason.
Yep.
Okay, before I dive into the actual demo, I want to spend a couple minutes talking about the architecture of our solution for Azure Databricks. So Unravel has a Azure VM and/or also potentially an Azure MySQL database that would need to be set up within the customer's Azure environment. And so the steps that you go through is you would set up an Azure VM, you would install Unravel with our RPM. This stuff can be automated with basically deployment scripts. And then we use a MySQL database to store our data historically, which has to be set up either on this Azure VM or you can use the Azure MySQL service. It's up to you. Once that's done, there is some Bootstrap scripts that you need to deploy on the Databricks workspace to allow the Unravel server to connect to your workspaces. And then there's some configuration with the Databricks automated job clusters. We are also shortly coming out with interactive server support in the coming days. And once that is set up, then you just simply log into the Unravel UI. There is a couple, as I mentioned, there is a couple of components that do get deployed on the Azure environment. We deploy to the cluster, and we have a daemon that communicates back to the Unravel Azure VM, collecting logs, making API calls on behalf of Unravel within each Databricks cluster, and you can configure it to monitor, each of the workspaces that you have. There's also a sensor that is basically a jar file that hitches a ride when a job runs and collects resources specific to the Spark job. It collects memory and it collects CPU and some other Java-related statistics, which I'll show in the demo. This information, again, is collected and stored and sent to the Unravel Azure VM. And our architecture is designed to be able to monitor multiple workspaces, multiple clusters, and keep this information historically for doing analysis such as cost management, chargeback, and also doing root cause analysis and trying to tune and optimize your jobs so that they use less resources and run faster. The installation of our solution typically takes an hour or two, and we've had customers who've actually done the installation entirely on their own, just following our documentation. So that's the, at a high level, our architecture. I want to jump into the product, and I'm going to talk about some of the operational insights that is provided within our solution to get visibility into how resources are being utilized across your instances and workspaces. So one of the things that's very powerful, which is distinctly different than the Databricks console itself, is that we can keep a lot of historical data going back for 6 months or longer, and you can pick a point in time and you can pick the granularity in which you want to collect, that you want to see data. And you can also, if you have multiple Databricks instances, you can either see the data across all of your instances in an aggregated view, or you can specifically select a specific instance. And then you can also filter on a specific workspace, or you can get information across all workspaces. And in this usage trend, we're able to see for a given workspace the number of jobs that are running over a period of time. In addition to that, we track the cost of running the jobs on the virtual machines. And then we also break out the DBUs, which is the cost that's associated with using the Databricks solution. So we can track cost across the workspaces. We also can provide this information from a user perspective. And think about this, because it allows us to track individual user that is using, that are running jobs across in all of the instances and workspaces. And we're able to track the cost as well as the DBOs broken down by the specific user. And the other thing I'd like to point out is that this data is accessible via APIs. So we expose all this data via REST so that you could feed this information into some type of an enterprise dashboard like Grafana, which we have customers doing today. The other part that I want to cover is chargeback. Being able to understand how the environment from a given period of time, again, we can go back for months or a year, we can filter on particular instances, and we can see which specific users are utilizing the cluster. And you can go back in time and pick a specific time period very quickly, and you can go back, 6 months or whatever, and from there you can see the usage by a user, what percentage, what are the, based on the total number of jobs that have been ran across all of the instances and workspaces, who are your top users, and which users are using, have the highest DBU cost. And from there, you can drill down further. So I can see a particular user, I can drill down on that user, and then I can see the usage of that user across all of the workspaces, as well as the DBU cost broken down by workspace. And this information gives you a list of each individual job that ran. And then you can drill down on that further and actually get some insights into that application and or potentially optimize it so it uses less resources and runs faster. In addition to this, we also have the ability to download this data to CSV. So we have a number of customers that export this information to an Excel spreadsheet, and they have a pre-built report that gets sent to their SVPs, so they have an idea of the cost of the platform across the different lines of business and for a specific project. And again, this can be automated as well if you want to access this information via APIs. We also break this out by workspaces. So if you're interested in understanding which are the workspaces that have the most applications and which workspace has the most DBU costs, we also break this out as well. And again, you can see the breakdown and then the actual applications that ran for a given workspace. So I talked about a little bit of the operational insights, but I also want to get into the ability to provide your end user with a self-service interface for them to be able to get visibility into their workloads on the Databricks platform. And this can be for a specific user, and that user can filter on a particular period of time, and they can filter by a specific application or the status of the application. They might be interested only in applications that recently failed and get some insights as to why it failed. I will show an example of that and how we can do some simple root cause analysis. We also have various tags that are provided to us by Azure that you can filter on. You can also filter by a specific workspace, the user that ran the job, the instance, and then also duration of time, as well as some other things. On the right-hand side, we can see the status of that job. Now, this is a static demo environment, but if it was a live environment, you would actually see jobs that are currently running, as well as jobs that have an end state, such as completed successfully or failed. The user, the application name. An important aspect that we do that's very unique is that as we collect metrics from Databricks API, from log files, from our sensor data, we take all this information, and then we have a machine learning process that looks for inefficiencies and then flags those jobs that have inefficiencies, where we can optimize it to use less resources, potentially recommend different instances or VM types to use so that the job will run just as fast, or if not faster, and use less resources, which obviously lowers the cost of using the platform. Then we also track the duration of time. If there is IO being written to Delta Lake or to the native Azure file system, we're able to track the read and write usage, which instance they ran on, which workspace, as well as some other internal information such as the job ID, job name, run ID. And then we also break out the total cost of running this particular job, as well as we break out how much of it was the DBU. Now from here, we can actually drill down and get lots of insights into a particular job. I'm going to show an example of that. So I've drilled down on a job that had ran, and I can see who the user that ran it, I can see what instance it ran on, the workspace, the cluster ID, as well as the costs for this particular job, the duration of time, the amount of IO, and so on. We also provide each of the Spark jobs associated with the Databricks job, as well as a Gantt chart to be able to understand the order in which the jobs are executed. If there are any error messages, whether that's a fatal exception or a warning, this information is all being captured from API calls from Databricks. We provide it all in a unified view. And we also capture interesting logs. This is something I'm going to emphasize more when I get into doing root cause analysis, but it's a key capability because it allows you to capture the driver and executor logs associated with the Databricks job. This is not a trivial thing, especially to get the executor logs within the Databricks console. It requires going through multiple hoops, and typically a non-administrative user is not going to have access to this. So that means that you're going to have to rely on your Databricks administrator to be able to track down this information to do any kind of deep root cause analysis. With Unravel, we provide all this information from this unified view and allow you to quickly do triage and understand what the root cause of the job failure. We also capture all of the configuration settings for each time the job runs. And when we compare the same job across multiple runs, we are able to see if there's any differences between the configuration, which could cause the job to run faster or slower. And there's other things that it could potentially cause the job to run slower, which we'll get into when I talk about tracking reoccurring jobs. We also have the ability to add custom tags. So some of our customers will do things like look at the metadata of the Databricks job, and based on that, enrich the metadata by adding custom key value pairs to distinguish which line of business, which project this particular job is associated with. And then from there, you can use that tag to be able to do breakdowns of usage and chargeback, which I showed shortly. You also have sensor information. So we have written our own sensor that will run within each of the containers that run within the Spark jobs for the Databricks job. And each container, we monitor the actual memory that's being used, the total memory available on the data node where the job is running. We also track how much CPU that this particular job is consuming on the data nodes, as well as the CPU overall on that data node. We also collect things like garbage collection, max heap, and used heap. All this sensor information basically provides you visibility into actual resources being consumed as opposed to what is allocated when you run the job from a configuration standpoint. We'll get into why this is so important, and it's a key capability of our solution that you do not get from the Databricks console or any of the Azure monitoring that's provided to you. So with all of the information I've shown here, there's a lot more I can drill down to get visibility into various metrics, but what we do is we analyze all these insights. We look at we run it through a machine learning pattern, and then we detect basically inefficiencies where we can provide actionable tuning recommendations. These are Spark parameters that you can set within your notebook the next time you run your job, and we show what the current values are and then what the recommended values are. These recommendations will basically allow you to run the job faster and potentially use less resources. And in addition to the recommendations, we also provide observations as to the efficiency of that Databricks job. So we are able to show you how, for example, how efficiently are you using the memory that you have allocated, and in some cases we provide actionable suggestions which are tied back to the recommendations. There will be another example when a job fails where we show why a job potentially failed. So you can quickly do root cause analysis. So this is an example of how you can optimize, you get visibility into the application and optimize it to have it use less resources and potentially run faster. Now I want to talk about another scenario, which is if you have jobs that are doing streaming operations. We have the ability to monitor the Spark streaming that runs within a Databricks job and monitor the latency and the latency as the data is coming in. Is the issue related to the streaming of the data coming in, or is it the process not able to keep up with the data as it's streaming in? And we track each of the micro batches, and we're tracking the breakdown of time that is spent in milliseconds for the schedule delay, the process delay, and total delay, as well as the operations. And we also provide, again, sensor information to track resource usage of the drivers and executors. And then if a job fails or is not efficient, we also provide, again, actionable tuning recommendations for not just a batch job, but also streaming jobs. We provide insights into how to optimize it so that the streaming can be processed data faster and more efficiently. We also can help with doing root cause analysis when a job fails. And so the key things that we do is, number one, as I mentioned, we grab all of the exceptions, the errors, the warnings, and then we also grab logs, which I'll show here shortly, and then the configuration settings. These are some of the key things that you would look at when doing root cause analysis, as well as sensor information to see how the memory was being utilized, or if there's some type of a CPU bound issue that you might have. Now, quickly, you can click on the events button and you can see there's another special tab called application failure. From here, we can quickly see that the reason this job failed is because it had an execution failure, that 4 of the executors basically ran out of memory. And we list out the things that you should check from a sensor standpoint and which executors. And again, that information is all provided here, all the different metrics as well as garbage collection, and you can see which executor. So I can quickly see that there was something going on with the executors number 1 and 2 with garbage collection because it spiked up to 20%. Now, in addition to this, obviously, you can scroll through here and you can quickly see a fatal exception that shows that, that there was an out of memory, as well as some additional errors, which could be a byproduct of basically running out of memory. But in addition to this, we also have the ability to drill down not just on the driver, but also the executors that had an out of memory error. And then from there, you can open up that log and you can scroll through it and look for the exceptions that occurred, which caused this job to fail. So here's the out of memory, and you can see the call stack error in all of its detail. This is very useful for doing root cause analysis. Okay, so now I'm going to move on to another aspect that is very unique to our solution. When you run a job, we're analyzing how much memory and CPU is being used, and we're comparing that how much is allocated versus how much is actually used. And then we also are aware of the VM types that you're using to run these Databricks jobs. From all of this, we're able to determine ways to basically save you money by recommending different instance types or VM types that use less or more memory. So if we know that your job is very CPU intensive but does not use that much memory, we will make a suggestion of an appropriate instance type that will optimize the usage of those instances and still have the job run as fast, if not faster, but at a reduced cost. If it's very memory intensive and not very CPU intensive, we'll then recommend a different VM type that is more, where there's more memory and maybe less cores. And so by us profiling the application, we're able to quickly identify areas where you can basically save money. And then you can go back and rerun the notebook and set which VM type that you want to use, and then rerun the job. So this is another aspect that's very unique to our offering. Now, the last thing I want to talk about is the fact that we track jobs that get scheduled to run. So many customers will have job clusters where they'll schedule reoccurring jobs on an hourly basis or daily basis or weekly basis. And one of the challenges that we've heard from a number of our customers is that if you go into Databricks, the history is very limited, and there's not an easy way to monitor a reoccurring job and identify trends. So one of the things that we do is we're able to quickly at a single unified view, we're able to see a reoccurring job. We're able to see the, in green, this is the duration of time for the last time that this job ran. We also track the average across all of the runs over a particular period of time. Again, the Databricks console only keeps data for a few weeks or a month. We can keep it for 6 months to a year. We can monitor many instances and clusters all in a single unified view. And we keep track of the reads and writes, the average reads and writes, and for the last run. Now, why this is important is because maybe the last job that ran was slower because it processed a lot more data. We can detect those types of anomalies and identify that very quickly. And then in addition to that, we can see a trend. So we can see if your job has an upward trend of taking more resources and running longer. And then from there, we can drill down, which I'll get into here shortly, but we also break out the total cost of all of the jobs runs for a given type of job for a period of time. So you can understand what the cost is to your business. Now from here, I can drill down on a particular job, and now we can see each instance or run, okay, based on different metrics such as duration, IO, number of applications that were ran, events, cost, and so on. From here, I can click on a particular data point, and that is a run for this particular job. Now it quickly will tell me, this job basically ran 40% longer than the average, and also the IO was 170% more than the average. So this might be the reason why the duration was much longer. Okay, now you can also compare other runs of the job side by side, and then from here I can drill down on the Spark job for this reoccurring Databricks job, and I can compare the two different Spark jobs side by side. I can see that this one has many more Spark jobs and stages versus the other one. Okay, I can also see the duration of time is significantly different. This one ran for 34 minutes, whereas this one below ran for around 5 minutes. And then I can also get in much further into the weeds. I can compare the configuration differences to see what's different between the two, and much more. And I can also look at recommendations on each of these runs to understand how I could potentially optimize this. So this is a unique capability that allows people to understand why a job that was running fast the previous week is now running slower, giving you quick insights. And then just to summarize, I showed some of the operational insights to understand how how to track cost and usage by the user across all your instances and workspaces. I talked about our chargeback capability, breaking out the usage by a particular user workspace. We also have the ability to do custom tags to do line of business and projects. I showed how a self-service user, you have a self-service interface for users to be able to see their jobs, get the status, be able to get insights into how to optimize that job so it runs faster, uses less resources. I talked about how we can monitor streaming jobs and be able to give insights into how to optimize it. I talked about how we could do root cause analysis and look at the logs, which are very hard to access from a Databricks console, especially if you're a non-administrative user. And then I went into how we can provide recommendations based on using different instance types based on the workload characteristics of the job. And then being able to track reoccurring jobs and understand why one job runs faster than the other and get insights into that. So now I'm going to stop my demo, and I'm going to hand it back to Jason to wrap this up.
Great, thanks, Scott. I'm going to go ahead and share my screen real quick. Scott, can you see my screen?
Yes.
Okay, great. So just have a couple more slides just to wrap things up, and we'll get on to the questions. So I wanted to share a recent customer engagement that we had at Unravel, where we helped a major media company reduce cost and guarantee service level agreements on Azure Databricks for their Azure Databricks environment. So this particular company, really their business model is to resell their analytics and reports for retailers. So many of their customers are consumer retailers, like a Kimberly-Clark or a Coca-Cola. And what they do is they harvest information, they harvest sales data from different retail outlets like a Target or a Walmart. And that helps the retailer manufacturers plan out their supply chain and demand capacity. So the product in itself is the analytic reports, and the subscription arrangement that they have with their customers is such that if the service level agreement window is missed, if their reports are not delivered in time, it actually incurs financial penalties for this particular organization. So it's really in their best interest to have top level performance and reliability for their Databricks jobs. So what we were able to do is really speed up that mean time to resolution of the failed jobs by providing those insights and furthermore recommendations into exactly why those jobs failed and the best remediation for those jobs. So they found that to be hugely useful. And in addition to that, we're able to skirt around some of the blockers from a security standpoint by enabling log information that they simply didn't have access to as an end customer. So let's say Kimberly-Clark wanted to look at the driver and executor logs, like Scott showed in his demo. They were unable to do that without enabling full administrative access to the Databricks environment, which they simply didn't want to do for security purposes. So using our tool, they are able to provide that self-service reporting and analytics into the root cause situation for their particular jobs as an end user. And that was a huge productivity boost for their end customers, as well as their internal staff who are monitoring these data engineering pipelines. And the end result is they're able to lower cloud costs for their infrastructure, and they're able to avoid over allocating a lot of the resources that seems to be a trap for many Azure Databricks customers. And they were able to do all of this using the Unravel platform. So I wanted to leave you with a few customer offers that we have on the table. So if you're an Azure Databricks customer that are interested in looking into our solution, we do have an Azure Databricks Azure Marketplace offer, as well as a listing on the Azure Marketplace. So we're offering financial incentives for you to simply sign up and try our product. So if you go ahead and subscribe to the Azure Databricks Unravel for Azure Databricks offer, then just simply reach out to us and we'll be happy to give you $2,000 in free Azure credits just for signing up. And if you want to explore a deeper level, what we call rapid POC, which is a completely remote guided install of Unravel for Azure Databricks, then we're able to offer you as much as $10,000 in free Azure credits, which we can negotiate with our account representative for that region. So we're happy to do that for you and help you get quick value from what's existing in your Azure Databricks telemetry to provide the cost-saving insights and recommendations that you're able to access today. So please send us an email, hello@unraveldata.com, and we could get that conversation started. So with that, let's move on to the questions that we have in the queue.
All right, great. We have, doing a quick time check, we have about 11 minutes to the top of the hour. Nope, 10 minutes to the top of the hour. So I think we have time for 2 or 3 questions here. Let's go ahead and dive right on in. First question, do you support Azure HD Insight as well, or only Azure Databricks?
Yeah, we absolutely support HD Insight. And we supported that actually before Azure Databricks, and that product is also available in the Azure Marketplace with the same incentive that I just outlined.
Okay, all right, great. Let's see. Excuse me, next question. Let's see, how Azure Databrick will help, how can Azure Databricks help DevOps to explore data science integration?
Yeah, I could take a stab at this. Maybe Scott, you want to jump in with additional commentary, but I think it probably would be useful to explore the complete portfolio of Azure Databricks products, and particularly MLflow, which is an open source project that Databricks has started and has huge expertise on. So what MLflow allows you to do is take the data that's been massaged using the Data Unified Analytics platform, and allows you to keep track of your experiments, allows you to manage your models and deploy your models into production using the Databricks platform. So I think that would help connect the dots in terms of how Azure Databricks will help data scientists in their experimentation. Scott, is there any other?
Yeah, it's a fairly broad question, but what I would say is also, if you're, basically have developed, jobs that are related to, doing stuff around data science, and you want to basically incorporate an automated process to go through CICD. I mentioned we do have everything exposed via REST APIs. You could incorporate these APIs to your CICD process to be able to identify whether a change to a job is going to cause inefficiencies, and then alert the CICD process. So there are a couple of our customers who have done this, and they've incorporated some of this in their CICD. It's not something that we do out of the box, but it's something that you could configure with assistance from our customer success, if that's along the lines of what you're asking.
Excellent. Okay. Next question. What would be the resource CPU and memory utilization percentage?
Okay, that's a good question. So one of the things that we're very conscious of is making sure that our monitoring solution doesn't cause any noticeable impact on your Databricks platform or the jobs. We don't want them to run slower. So if you saw my architecture, the 99% of the workload is done on our Azure VM that's outside of the Databricks cluster. However, we do have a daemon that is collecting data. It's just making API calls periodically, which is configurable to the interval. We also have a sensor. The sensor is very lightweight. It takes per container, it's about 10 megabytes of resident memory. It basically sends out about 20 metrics on a set interval that's configurable. So and then as far as CPU, it's negligible. You will never be able to notice our CPU overhead on anything within your Databricks cluster. But from a memory footprint, there's a little bit of resident memory. It's basically megabytes, it's not gigabytes. So it's never been an issue with some of our large customers that run very large workloads in a large cluster environment.
Okay, all right, great. I think we have time for one more question here. Can I see jobs from multiple workspaces on a single Unravel deployment?
Absolutely. The whole point of what we have, the way we architected this is so that we can monitor multiple clusters, multiple workspaces with a single Azure VM that you would have running all the time to keep the history of all of the jobs that you ran across all of the clusters and workspaces. So that's a core requirement when we've designed this solution.
All right, great. I'll Heck, let's do one more question, then we'll close it down. Do you support AWS EMR and GCP Dataproc as well?
Yeah, we absolutely do. We do support Elastic MapReduce from AWS, and we just released a few months ago the complementary product in GCP, which is Dataproc. So both of those solutions can be found on our website.
Excellent, excellent. Okay, well, we are about 5 minutes to the top of the hour, and conveniently, that's all the questions we have. So I'm going to go ahead and shut down the question and answer period. Thank you very much for everybody who did submit questions. Good stuff there. And I do want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. We will be sending out an email post-webinar that contains a link to access the webinar on demand. And the webinar is also going to be living on the DevOps.com website. So you can always go find it there. Just go to DevOps.com/webinars, look in the on demand section, and it should be right there waiting for you. Also at the top of the hour, I did mention that we would be doing a drawing for two $50 Amazon gift cards. So without further ado, let's go ahead and do that. Our first Amazon gift card winner today is Charles W. Congratulations, Charles. And our second winner today is Andre Y. Congratulations, Andre. We'll follow up with both of you offline by email to get your gift card over to you. So please check your inbox for an email from us. Jason and Scott, thank you so much for a great presentation today. Lots of good stuff. Really appreciate it.
Thanks, Charlene. Appreciate it.
All right. Great. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody. Stay safe.
Bye-bye.